An LRU cache is a fixed-size cache that, when it runs out of room, throws away the least recently used item. It's everywhere: your CPU's caches, databases, web servers, even Python itself. The challenge: make every get and put run in constant time. Today we build one from two data structures we already know. A cache speeds things up by remembering recent answers, but memory is finite, so it needs an eviction rule. Least recently used is the most popular. Keep what you've touched recently, discard what you haven't. To pull that off in O of 1, we need two things at once: instant lookup by key, and instant tracking of which item is oldest. No single structure gives us both. The first half is a hash map. It gives us the lookup, hand it a key, get back the value in constant time, no scanning. But a hash map has no sense of order. It can't tell you which key was used longest ago. For that ordering, we need a second structure working right alongside it. The second half is a doubly linked list, which keeps items in order of use. The most recently used item sits at the front, the least recently used at the back. When you access an item, you splice it out and move it to the front. When the cache is full, you evict from the back. Because it's doubly linked, every one of those moves is constant time. Python hands you both halves in one object: OrderedDict, a dictionary that remembers order. On a get, fetch the value and move that key to the end, marking it most recent. On a put, set the key, move it to the end, and if we're over capacity, pop the oldest item from the front. Get and put, both O of 1. And if you just want to cache a function's results, you don't even write a class. Functools.LRU Cache is a decorator that wraps any function with exactly this machinery: a hash map plus a usage order, bounded by max's eyes. Internally, it's the same dict and linked list trick you just saw, battle-tested and written in C. When is LRU the right policy? When recent usage predicts future usage, which is true surprisingly often. Web and database query caches, image and asset caches, memoizing expensive calls. Reach for OrderedDict or LRU Cache when you want it handed to you, and build the hash map plus doubly linked list by hand when an interviewer asks. Skip LRU when access is truly random. The LRU cache is a perfect lesson in combining structures: a hash map for lookup, a linked list for order, constant time on both. And notice every decision came back to one thing: big O. Next, we make it the whole topic: big O notation, the language behind every choice we've made across the series.